In the last video, we finally finished our reinforcement learning simulation environment. Well, maybe not this game-like visualization just yet, more like a text representation. Let's call it version 0. But this is good enough to train a reinforcement learning agent with. Before training, we should test the environment to make sure it works as expected. Down at my main block, let me paste in some code. This is pretty typical code for running a simulation environment. First, we're creating an instance of our environment, resetting it to an initial state, initialize the termination flag. We'll use total reward to accumulate the rewards collected in the simulation, and the step counter just counts how many actions we took. While the simulation has not been terminated, we'll choose a random action by calling the sample function from the action space. We'll take that random action and we'll pass it to the step function. The step function gives us back the observation, reward, and terminated flag. We'll accumulate the reward, increase our step counter. We'll print out what action we took. We'll print out the observation. The observation is the state of the environment after taking the action. And we'll print out the reward that was given back to us. This loop will continue until eventually everybody on the plane has sat down, and then the terminated flag will be true and we'll exit the loop, and then we'll print the total reward collected. Let's run this. I'm going to hit F5. Oh, there is an error. There is a flaw in the environment. Let's walk through the simulation and then we'll talk about what that flaw is and how to fix it. This is the initial state. We have 15 seats, nobody in the boarding line, and 15 passengers in the lobby. The first action that was taken is 2. 2 is, row 2 is this, so it's taking passenger 14 and putting passenger 14 into the line. We can see that the observation is correct. First spot, which is this spot, there's nobody. There's also nobody in the second spot, and then in the third spot is passenger 14, and passenger 14 is moving, represented by 0, and then nobody else in the line. And we get a reward of 1 because we have one passenger that's freely moving. So far so good. Now in the next action, it also randomly selected row 2, and passenger 13 went into the line. Passenger 14 happens to be in the row that they're gonna sit in, so they started storing their luggage. So passenger 13 has been stalled, and we can see the observation reflects what's happening, and we get a reward of -1 because there is one passenger stalled and nobody else is moving. Let's do one more. Now in the next action, we're selecting somebody from row 1, which is right here. So passenger 9 went into the line. Passenger 13, which was stalled before, moved up since passenger 14 sat down, and we get a reward of 2. So far the environment is working as expected. Now instead of walking you through the rest of this, let me jump straight to the problem. This is the printout right before the error occurred. And as you can see, row 0 and row 1 in the lobby still has passengers, but row 2 no longer has any passengers to choose from. What happened when we randomly sampled the action space, it selected 2 again, and it crashed because I didn't handle the case of taking a passenger out of an empty row in the lobby. Now I could fix the code and handle that case. Basically, when we select row 2 again, we'll just pass no action to the step function. Essentially, we don't send anybody to the line in the next step. But that's not the best way to handle this, because as the simulation goes on and the lobby empties out, we're going to have a lot of empty rows. So there's going to be a lot of times when the actions does nothing. And if we were to perform training on a lot of actions that does nothing, all it does is waste training time. The right way to do this is to use action masking. Let me try to explain this on Super Mario, and then we'll go back to our environment. Now most of the time Mario can either go this way, or jump. So 3 actions. while the other 3 actions are essentially useless. Now obviously it will be better to train Mario on 3 actions rather than on 6 actions where half of them don't do anything. And then when Mario gets to this state, the down action is now valid because he can go down the pipe. So now he has 4 valid actions. Essentially during training we want to be able to select from a valid set of actions depending on the state of the environment. Now how does it apply to us? Going back to the example, let's stick with what we were running with, 3 rows by 5 seats. And the way we can create the mask is just by returning an array of true or false. True if the action is still valid, and then false if this action is no longer valid. Very straightforward. There are a few ways we can implement this. Let me stop this one and head over to my airplane env, and I'm going to add a new function. I'll just add it at the end of this class. The function must be called action masks. It returns a list of booleans, and we're simply looping through the rows in the lobby. If there are no more passengers in that row, we'll append a false into the list. Otherwise we'll append true. And that is it for the mask. This function must be named exactly the way it is, and it must belong to our simulation environment. And the reason why we're implementing it this way is because we're going to be training the environment using the PPO algorithm, or a modified version of the PPO algorithm that handles action masking. And the PPO algorithm is part of the Stable Baselines 3 library of reinforcement learning algorithms. Let me go down to the RL algorithms, and it's listed right here. It actually belongs to an extension of the Stable Baselines 3 library. Let me open this up, and I'll follow the documentation link. This is where it talks about maskable PPO, and it tells us that we must implement this function inside our environment. Now let's finish testing, and I'm back at my main block. Right after selecting the random action, I'm going to add a few lines here. And all we're doing is calling the action mask function to get the mask. If the action in the mask is false, just continue the loop and let it keep going. Note the way to call a function that is not part of the gym interface. So step and reset is part of the gym interface. So that's why you can call env.step or env.reset. But if your function is not part of the gym interface, you have to call unwrap in order to get to our class. So just think of unwrap as a way to get down to the airplane env class. Okay, now I'm going to hit F5, and it should be able to run all the way through, and it does. Okay, now we have an environment that's ready to be trained. Join me in the next video, and we'll try to use maskable PPO to train a reinforcement learning agent.